Good afternoon.
Good afternoon, sir.
Let's wait for 1 or 2 more minutes. Then we'll start. Is it visible, the slideshow?
Yes, sir.
Okay. So, one more minute we will wait, then we'll start the session. Okay. So, let's start it. So, it is our second module as per syllabus. Okay. And so far we have covered 3 modules. So it will be our fourth module. Okay. Here in this module, some special mechanisms have been covered. What these mechanisms are used for. Okay. And what are these and how their construction is, we will see in following slides. Okay. So one of the special mechanisms which we will be dealing with are the straight line generating mechanisms. So as the name suggests, that purpose of this mechanism is to achieve the straight line of any point which is present on any link of the mechanism should trace or should move in a straight line. Okay. So that suppose if you want to perform some cutting operation, you will attach the cutting tool at that point of the mechanism. Okay. And with the help of its to and fro motion, the cutting operation will be performed. So it is the significance of having straight line generating mechanism. Okay. So these mechanisms, that is straight line mechanisms, they could be tracing an exact straight line as I have shown it. Okay. And there are some mechanisms which trace an approximately straight line like this. Means any point on the mechanism will move in this particular path which is not exactly straight. Okay. So it can be said as approximate straight line mechanism if it is not generating the exact straight line. Okay. So that is the two classifications of straight line mechanism. One is exact and the another one is approximate straight line motion mechanism. Okay, again, these mechanisms can also be classified as ones in which only turning pairs are used. Okay, that link will rotate with respect to each other, they will not slide. Okay, so there are mechanisms which make use of only turning pairs to achieve the straight line motion, and there are some other mechanisms which use at least one sliding pair. Okay, and that sliding pair will generate the straight line motion. Okay, as you know that when piston slides in the guides, so motion of the piston is constrained to be in straight path. Okay, so it is about the straight line generating mechanism. First we will see which are the exact straight line motion mechanism. Okay, so next topic is our that exact straight line motion mechanisms which are made of only turning pairs. Okay, there are no sliding pairs.
So can you show the previous slide for a second?
Yes, see.
Thank you, sir.
Okay, so as the name suggests that any one point on this mechanism will be moving in a straight line. Okay, and with the help of that point we can achieve the desired operation. That motion of that point will be useful to us. Now, how these mechanisms work, which are just made of turning pairs, and they give us the straight line mechanism. So they work on one principle. Okay, I will tell you what is that principle. Suppose it is a circle. Okay, OP is the diameter of the circle. Okay, now you join any chord, that is OA is any chord of the circle OA. Okay, now what you do, you extend this chord like this. Okay, up to point B, such that the product of this OA and OB should always remain constant. Okay, so in this I considered this chord OA. Okay, similarly, if I consider any other chord, like say if I consider any other chord like this, so here my point will be OA1. Okay, here is the point A1. Now you have to extend this chord such that this product should not be affected. Okay, so you can see that now the value of OA is changed, it has increased. Okay, so in order to keep this product constant, I must keep OOB1 less as OB. Okay, so I will again extend this chord. Okay, and here I will get a point B1. I extended this chord so that this product should not be changed, it should always remain constant. Okay, so if you go doing this, okay, you will find that the locus of the point, the locus of the point is a straight line like this. So you can achieve point B, B1, B2, B3, all these points will be moving in a straight line, and that straight line will be perpendicular to the diameter diameter of the circle. See, like this. So if you can achieve this, if you can achieve this product constant, okay, in different configuration of the mechanism, then it is possible that point B will move in a straight line. Okay, I will prove it. So see, what is done to prove it. Point A and point P is joined. Okay, as these 2 points are joined, you know that angle at point A will be 90 degree. Okay, from you know the geometry, this angle will be 90 degree. Okay, so from here there will be two similar triangles. Which are those triangles? Triangle OA, triangle OAP. Triangle OAP will be one triangle. This triangle will be similar to, so triangle O के बाद कौन सा पॉइंट लिया था, where 90 degrees there. Okay, so triangle OQB, it will be similar. OQB, like this. Why these two triangles are similar? First is that point O is common in them, so one angle is common. Second, in this two triangle, you will find there is one right angle point, right angle. So at point A there is a 90-degree angle, and here in triangle OQB, at point Q there is 90-degree angle. So two angles are same. Third will also be same. Okay, so that's why these two triangles make the similar triangles. Okay, so using the similar triangle principle, you can write that the ratio, ratio OA, this ratio OA upon OP. Okay, ratio OA upon OP, this ratio will be equal to, here यहाँ पे लिया था OA, तो यहाँ पे क्या होगा, OQ. Okay, OQ upon OP. So here OB, we can write it like this, as these two are similar triangles. So from this equation you can write the expression for OQ. Okay, you can write OQ as OQ is equal to OA into OB, OA into OB upon OP, like this. Okay, say this is equation A. Okay, now here you concentrate that what is distance OQ. So OQ distance is what? That you extend the diameter OP, okay, and from point B you draw a perpendicular to this diameter, or diameter extended. So where this perpendicular will cut this horizontal diameter line, okay, there you measure the distance OQ. Okay, and suppose if point B should always move in a straight line, then whenever you draw the perpendicular from point B, must always pass through point Q. Okay, suppose if you get point B somewhere here, suppose it is B1 point. B1 point is here, and if you draw the perpendicular through that to the horizontal diameter extended, so value of OQ will change. Okay, if value of OQ will change, means point B is not moving in a straight line. It has changed its route. So in order that point B should move always in a straight line, this OQ should be constant. Get, are you getting it?
Yes, sir.
Okay, OQ should always be constant. Okay, now as per the equation, you can see OP is what? OP is nothing but the diameter of the circle. So diameter of the OP is the diameter of circle, means OP is constant. Okay, now as OP is constant, to keep OQ constant, this product OA into OB must be constant. If you can anyway maintain this product OA into OB as constant, then you will achieve a straight line motion from any point. And which is that point? It is nothing but the chord extended in such a way that this product is constant OA into OB. Okay, so how will be the motion? Motion will be such that this point A will be moving along the circumference of the circle. So here it is the point A1, point A2. Okay, point A2, or it can it can also be here that point A will move in a circle, and point B it will move in a line, in a straight line like this. Okay, so you note it down in order that point B traces an exact straight line. The product OA into OB, it should always remain constant. This is the principle on which the exact straight line mechanism which are made of turning pairs work. Okay, so you note it down, then we will proceed with the mechanisms. Done.
Yes, sir.
Okay, so next I will cover the Okay. So following two mechanisms are there, okay, which consist of only turning pairs. There will not be any sliding pair, okay, which gives us the exact straight line motion of any point. So this mechanism, first one is P-Celier's mechanism and Hart's mechanism. Okay. So first we will see the P-Celier's mechanism. So see here how it consists of, how many links are there. Okay. So links are shown in blue lines here. Okay. Links are shown in blue lines and other lines are construction line. So as you can see, it consists of 8 links. So you can count O1 O. It is fixed link. It is first one link. Then from point O1, one link is connected. That is point A. O1 A. It is second link. Third link, third and fourth links are connected at point O. So OC and OD. 4. And remaining 4 links you can find in this parallelogram. So A, C, CB, BD, and AD. These are 8 links uh, by which this mechanism is made of. Now here certain geometrical relations are followed. For example, these 4 links AC, CB, BD, and AD all are equal in length. Okay. Then link OC and OD, these two links are equal. OC, link OC and OD are equal in length. Okay. Then this O1 O, this link, fixed link, is equal to the rotating link O1A. Okay. So what will happen when crank O1A, when this crank O1A will rotate about point O1, so point A will move in a circular path. Okay, as point A is on radius, it will move in a circular path, and we have to prove that point B will be moving in a straight line. Okay, so in order to prove it, what we need to prove? We need to prove that the product of OA, okay, into OB, okay, OA into OB is constant. We have to prove it. Okay, so to prove it, how we can prove it? So first you consider this triangle. Okay, so you can see it is a rhombus, and because of these relations between the length of different links, when you will join point O and point A, so this line will be passing through point B. Okay, because of this equal link lengths, these two are equal. Then these four are equal. This, so obviously point O, point A, and point B. These 3 points will be in a straight line. Okay. Now you consider these two triangles, which are the right angle triangle ORC. It is one triangle, and second is triangle BOD. RC. So in this true triangle, what we can write? See, ORC and BRC, this triangle. Pythagoras theorem, you can write OC square. This diagonal square is equal to the square of remaining sides. OR square plus RC square. It is written OR square plus RC square. Similarly, for triangle BRC, okay, what you can write? BC square is equal to BR square plus RC square. BR square, RB square plus RC square. Okay. So what next? You can see RC is common. So by subtracting equation 2 from equation 1, we can eliminate the RC square. So OC square minus BC square is equal to OR square minus RB square. This RC square and this RC square will get cancelled. Okay, this and this will get cancelled when you will subtract the equation 2 from equation 1, and you will get like this OR square minus RB square. So here you can use the formula of A square minus B square. So you can write it like OR plus RB in bracket OR minus RB. Okay. Now you see what is it OR plus RB. So here OR, see OR plus RB is nothing but OB, correct? OR plus RB is nothing but OB. So this term is equal to OB. And OR minus RB. So OR minus RB. Minus RB means AR will be equal to RB. So OR minus AR, it will be equal to OA. Okay, these two will be same. So you can say that AR will be equal to RB. So OR minus RB is nothing but OR minus AR, and OR minus AR is nothing but OA. So this product is OB, this term is OB, and this term is OA. OB into OA. Okay, so our aim is to prove that this product is constant in order that point B is moving in a straight line. Okay, in order to prove that. So you can see it is the right hand side. On left hand side, what is there? On left hand side, there is OC ka square minus BC ka square. So what is OC and BC? See, OC is the link. So link ka length hai. So link length will not change. It is constant. What is BC? BC is also the link length. So it is also the constant. So subtraction of two constant will be constant. Okay, so on left hand side there is constant, and on right hand side there is the product of OB into OA. So you can say that the point B is moving in a straight line. We already proved that if this product is constant, the point B will move in a straight line, and the path of point A is what? Path of point A will be moving in along a circle. Okay, and this straight line, it will be perpendicular to the diameter extended. So O1, you extend this, here you will get the diameter P, point P, and then extend it. So It is the path of point B, path of point B. Okay. So I will again show you its video, how it works. I request all of you to put down your attendance. Try to give the attendance in first session only. So sometimes this is asked that explain the P Sellier's mechanism. Okay, so you need to explain it, how many links it has, what is the geometrical relation between the dimensions of links. Okay, then you can prove it. You can prove that point B is moving in a straight line. Okay, so getting it.
Yes,
Yes.
sir.
Okay. Others, if you have any doubt, you can ask me. Okay. Anyone, if have any doubt, can raise it anytime. Then after Pucelier's mechanism, we will see the Hart's mechanism. Okay. So see, this is the Hart's mechanism. So this mechanisms requires only 6 links as compared to the Pucelier's mechanism where 8 links are required. So here you can count the number of links. So here O1, it is link 1. Then O1A, it is your second link. Okay. Then this link CF is your third link. Then CD, CD is your fourth link. Then FE, FE is your fifth link, and ED is your sixth links. So this is the mechanism. Link O1O is fixed, and at point O1 you have attached this crank O1A. Okay. So what is the expected motion from it? That crank will rotate. It will rotate completely. Okay, through 60-degree. Point A, it will be moving along the circle. Point A will be moving along the circle, and it is expected that point B, which is on link EF, point B link EF पर है, देखो यहाँ पे. So it is expected that point B should move in a straight line. Okay. So, and what is the position of that straight line? That this straight line is perpendicular to the diameter extended. So it is the diameter. OP is the diameter. You extend it and you draw a perpendicular to this diameter. So it is the path of point B. You can see it is a path of point B. But we have to prove that point B is moving in a straight path. So for that, what we need to prove? We need to prove that this product OA the product OA into product OB is constant. Sorry, distance OA and distance OB का product is constant. Okay, so we have to prove it. Okay, so first let us see what are the relations of lengths of different links. Okay, so one can easily see that the links CF and ED, these two links are equal in length. Okay, if suppose you do any mini project where you want to make the hearts mechanism, so these proportions, okay, you need to maintain, otherwise you will not get the straight line motion from point B. Okay, second thing is that the link CD is equal in length of link EF. Okay, and O1O, this link is equal to O1A. These are the geometrical relations. Okay, next, so these 6 links are there and they are geometrically related like this. You need to have these relations maintained in order to achieve a straight line motion mechanism. Next, you can see that there are points, point O, point A. Point O is on which link? Point O is on link CF. Point A is a point on link CD and point B is a point on link EF. So its position will not change. The position of point O. Okay, what is given here? That points O, A, and B divide the links FC, then CD, and EF in the same ratio. Okay, so this ratio is also maintained. So after deciding the length of the links, now you need to decide where is the point O. Okay, so wherever you take this point, you must maintain this ratio. What is this ratio? OC upon FC. This ratio must be equal to AC upon DC, like this, AC upon DC, and similarly BE divided by FE. This ratio must be maintained. Okay, and if you maintain this ratio, okay, so because of maintaining this ratio, what happens? See this triangle. So you consider the triangle C F and D. C F D. This triangle, it is similar to the triangle COA. Getting it? COA. Because you know this, you are maintaining this ratio, and it is the property of similar triangles. Okay, which two triangles I have considered? So we, how much time is remaining? Just let me. Less than 1 minute is there. So you have to join back immediately. Then we will proceed further. Okay.